Figure 9.1 through 9.3, the time class definition. In this example, we're going to introduce the time class, which we'll be using throughout this lesson and the next lesson to introduce various object-oriented programming concepts in C++. So in this example, what I wanted to do was start with the main function and show you how we use the class time, which is included from the time.h header file. And after we show you how we use it, we'll go back and take a look at its actual implementation details. So you can see here in main that we've created a time object called t. Now remember, when you create an object of a class, C++ requires that the object have a constructor call to initialize its data. So even though we don't have a set of parentheses here, there's a call happening to a constructor that takes no arguments. Such a constructor is either the default constructor that's created for us when we don't define any constructors in our class, or it's a constructor that we explicitly define to take no parameters. In our case, in this example, as you'll see, it's a constructor that we explicitly defined to take no parameters. In either case, the time object t is going to receive a constructor call after line 12, or as part of line 12, I should say, to ensure that the time object is initialized before we move on in the program. Now, in this program, the time object is going to be storing hours, minutes, and seconds, and representing the time in 24-hour clock format. So the hour will be a number from 0 to 23, and the minutes and seconds will each be values from 0 to 59. And to start out, when we initialize a time object, we're going to give it all zeros for the hour, minute, and second, which is the equivalent of midnight in standard time. So at lines 15 through 18, we want to prove to you that the object got initialized properly. So we tell the object t to print itself in universal format. Then we tell the object t to print itself in standard format. And I've already executed the program, so you can see the first two lines of output here, all zeros for the universal time, and we display that as 12 a.m. for the standard time. Next, we want to set the time using our member function setTime, which takes three integers representing the hour, minute, and second. So we tell the time object to set its time to the three arguments we specify. And assuming it worked correctly, we should be able to display the time now, showing 13, 27, and 6 for the universal time, or 1:27:06 p.m. for the standard time. So if I stop there and I go to this next block of output, you can see we once again tell the object to display itself in universal and standard formats. And now if I switch back to my output, you can see 13, 27, and 6 for the universal time. And 13, of course, is 1 o'clock in 12-hour clock format, so 1:27:06 p.m. in 12-hour clock format. Now, the setTime function happens to perform some validity checking as well. One of the benefits of using an object of a class is that you can have the member functions that you define check all the arguments that they receive to make sure they're valid for use with objects of the class. In this case, we're trying to pass in values of 99 for each of the hour, minute, and second, which are all out of range. Hour, again, needs to be 0 to 23. Minute and second each need to be 0 to 59. So after telling the time object to set its time to invalid values, let me go ahead and display once again the results in universal and standard format, and you can see that my universal time is set back to all zeros and my standard time is back to 12 a.m. And the reason for that is, in our example, we've defined the setTime member function so that it's going to set any invalid value it receives to 0 before storing the value into the hour, minute, or second, respectively. Now, that's one way that we can go about handling invalid values. Another way would be to simply ignore that value and leave what was already in the time object alone. And a third way would be to use what we call exception handling, which is one of the key topics in the C++ Fundamentals Live Lessons Part 2. Now, when we get to exception handling, we'll see that one of the things we can do when we receive bad data values is throw exceptions indicating that a problem occurred. And the client code will then be told that a problem occurred and be able to catch that problem and try to handle it, try to do something to correct the problem, or at least shut down the program in a nice manner. So in this case, like I said, we're setting everything back to 0, which we'll look at in the implementation of class time in just a moment. Now let's take a look at the time class's header file, and we'll start with lines 10 through 21, where we define the class. As we've done previously, we start with the keyword class followed by a class name, and by convention it starts with a capital first letter, T in time in this case. We have a public interface to our class where we're listing out the different member functions that we provide. And then in our private section, we see that we have 3 integer variables representing the hour, minute, and second, respectively. Now, at lines 13 through 16 in the public interface, we have a constructor which takes no parameters in this example. And by the way, we know this is the constructor because it has the exact same name as the class and no return type, both of which are requirements for constructors. We have a setTime member function that returns void and expects to receive integers for the hour, the minute, and the second. Then we have a print universal and a print standard function, each of which returns void and takes no parameters. Now, one thing that's new in terms of the class definition in this example is the set of preprocessor directives at lines 6, 7, and also line 23. This is called a conditional compilation directive, and basically the purpose of this is to ensure that the class definition for time only ever gets included into a given .cpp file once. As you start to work on much larger projects, it's not uncommon for the same header files to be included many different times across many different source code files. And sometimes you can accidentally even wind up with the same header file indirectly or directly included multiple times into one .cpp file. If that were to happen without this preprocessor wrapper, as we call it, then what you would wind up with is multiple definitions of class time, and the compiler will actually issue multiple definition errors in that case. So to prevent accidental includes of the class time more than once in a given .cpp file, we wrap each class definition in this preprocessor wrapper that starts with a #ifndef directive, which says if not defined the name that I've specified. If this name is not defined, let's define it. Then we'll include the class definition, and that will be the end of the preprocessor wrapper. The next time the same header file gets included into the same .cpp file, time_h will already be defined, so this condition at line 6 will be false, and therefore we won't include everything that I've just highlighted in lines 7 through 22, and because of that we won't wind up with an extra copy of the time class in a given .cpp file. Now, by convention, the name that you use in these conditional compilation directives typically is the same as your header file name, but we replace the dots with underbars because dots are not allowed in preprocessor symbolic names. And then separately, we also typically place the name in all capital letters to make it stand out as well. So I came up with time_h by making time.h all caps and replacing the dot with an underbar. So again, use these preprocessor wrappers around every class that you define just in case, and it helps you to prevent multiple definition errors, in your programs. So now let's take a look at class times implementation. And we're using a couple of new features in this example. In particular, we're using the parameterized stream manipulator called setFill. And we're going to use this to help us ensure not only that each of the minutes and seconds, regardless of whether it's universal time or standard time, is displayed in 2-digit format, and also the hour for universal time will always be displayed in 2-digit format. And for single-digit numbers, we're going to have a leading 0, and we're going to do that by setting the fill character to 0. So we'll see how we do that in just a moment. And we'll also take advantage of setW again to specify how many character positions a value should occupy on the screen. At line 10, we include the time header file because we need that in order to be able to define the member functions that are in the scope of class time, such as the time constructor, which is specified to be in the scope of class time here at line 14. Our constructor must have the same name as the class, and in this case the parameter list is empty, meaning that we don't expect to receive any arguments when a time object is created. Now in the body of this particular constructor, we're simply assigning 0 to the hour, minute, and second. In case you haven't seen this before, this is evaluated right to left. 0 is assigned to second, Then seconds value is assigned to minute, and of course second is now 0. Then minutes value, which is now 0, is assigned to hour. So this is going to ensure that every single time object we create using this version of class time will start with its hour, minute, and second set to 0. Next, we have the setTime function, which is also in the scope of class time. And by the way, for both of these member functions, that's important because neither of them is defining variables called hour, minute, and second. It knows to go look in the scope of class time for the declarations of those variables. Same thing down here. So setTime receives integers representing the hours, minutes, and seconds, and we're using the conditional operator in each of the lines here to test the value that's received as an argument, and if it's in range, assign it to the hour, otherwise assign 0 to the hour. So let's see how we do that here. First, we evaluate this highlighted expression, h greater than or equal to 0 and h less than 24. If the h value is in that range, it's a valid hour, in which case we'll assign the value of h to hour, otherwise we'll assign 0 to hour. And similarly for the minute and second, if each of their values is greater than or equal to 0 and less than 60, then we'll assign the minute or second to the minute and second variable respectively, or 0 if necessary. Now for our two print functions, you can see here that for the print universal, we're setting the fill character to 0 first, and this is one of those sticky stream manipulators, meaning it applies to everything going forward. Anything that we output in a field that's larger than the number of characters required to display the value will be preceded by leading zeros. Next, we say in a field of 2 that we'd like to output the hour. Now, if the hour is a number from 0 to 9, it will be preceded automatically by a 0. If it's 10, 11, or 12, or actually I should say all the way up to 23, 10 through 23, then it will simply display the value of the hour followed by a colon. Then we'll display the minute in a field of 2, possibly preceded by a 0, and then we'll display the second also in a field of 2, possibly preceded by a 0. In the case of the print standard, we want to do 12-hour clock format. So first we determine if we should display 0 or 12. I'm sorry, not 0 or 12. 12 for the midnight or noon hours. Otherwise, we'll display hour modulus 12. So if the hour is equal to 0 or the hour is equal to 12, display a 12. Otherwise, give me 1 to 11. 0 will not be one of the possibilities for this highlighted expression in this example because we've already dealt with the 0 case earlier in the expression. So we'll follow the hour in 1 or 2 digit format with a colon. Then we'll set the fill character to 0, and we say let's display in a field of 2 the minute and a colon, and then in a field of 2 the second, followed by the string AM or PM, depending on whether hour is less than 12. So we've got our formatting here, and again, the new feature in the formatting is the use of the setFill stream manipulator. Now, in subsequent examples, both in this lesson and the next, we're going to look at many enhanced versions of the time class. In a couple of videos from now, we'll take a look at a version of this time class that has set and get member functions for every piece of data, and also has a more robust constructor as well.